Today's topic is open geospatial datasets from Mobility Lab Helsinki, data catalog. I'm Jukka Alander from Virium Helsinki. I'll give a brief introduction to what Mobility Lab Helsinki is, and then Aalto University students will tell about their project more in detail. So, a few words about Mobility Lab. It's a collaboration project between the City of Helsinki and the city innovation company Virium Helsinki. And the aim is to provide a testbed for all the mobility-related activities inside Helsinki region as a physical testbed, but also as a virtual testbed by utilizing existing datasets that we gathered in different pilot projects through the years. So we have captured a mobility laser scan data from one of our test sites in Jätkäsaari, downtown Helsinki. And in this project, Aalto University students used this dataset. And the testbed itself is allowing companies to develop their services and pilot different kind of solutions in real-world environment. So, building together an ecosystem of companies and data interoperable together, we might say that it's building a digital twin part by part. These are the objectives of the Mobility Lab and the testbed in general. And the data catalog where this mobility laser scan data is used from can be found through this link and through Virium website. So Virium Helsinki is a non-profit innovation company of the City of Helsinki, and we worked together with companies, research, and citizens. And now to Aalto University students, they tell how they utilize the data from the mobility data catalog.
We are Juha, Ilkka, Anna, and I'm Johanna, and we are students from Aalto University's master program in geoinformatics. And we had this project course with a few different real-life topics for second-year master students, and we chose this topic given by Virium for benchmarking current open point clouds. So we did an assessment of suitability of different laser scanning approaches for urban environment management as a case study in Jätkäsaari. So we had 4 goals and a few outcomes that we wanted to produce. So firstly, we needed to gather a georeference dataset with terrestrial laser scanner from Jätkäsaari area. Then we pre-processed the data and prepared the resulting point cloud for open release. And then we compared this dataset to these experimental datasets that already existed. And finally, we produced a report evaluating different datasets and their suitability for applications of urban environment management. And here are the 3 datasets that we used in our project. So first we have this terrestrial laser scanning data that we collected with this Leica. And then in the middle we have this cyclomedia mobile laser scanning data. And on the right there is the Hero delivery robot data. And yeah, next Ilkka will show how these datasets are aligned and how easily they can be used.
Yes, we started to have like make the cloud-to-cloud analysis from whole point clouds. So first we see that the georeferenced point cloud cloud-to-cloud it's have problems with alignments. So we do the ICP registrations And after the registration, we make the cloud to cloud again, and it seems like all the points of streets and buildings are under the centimeters accuracy. And this is gyromedia, and we do same thing as the delivery robot data, and same alignment problems there. And after registration, it's the streets getting better, but the walls of the buildings are still quite problems, and also there is very noisy the point cloud.
Yeah, and then we are moving on to comparison results and the evaluation of suitable applications. So first, we have the 3D model, and for this we ran a density analysis tool that's based on the number of neighbors within a given radius. And for this, we downsample all the 3 datasets for optimizing the processing time. And based on the results, you can see that cyclomedia seems to have a similar density distribution compared to the latest one. And in contrast, the delivery robot data seems to have a significantly lower density than the other two, making it unsuitable for high accuracy 3D city modeling. And we also visually evaluated the construction of buildings and their walls and corners. And for this, we aligned the data sets with ICP and then looked at the segmentation of the walls. So in general, the cyclomedia seemed to capture details of buildings in good detail, which makes it suitable for creating a 3D city model with high level of detail. And the robot data, on the other hand, seem to face challenges in capturing detail and maintaining consistent point density, especially for buildings that are taller than a few meters. But we still think that depending on the desired level of accuracy, the robot data might be suitable for creating a large-scale 3D city model where the focus is on building outlines instead of fine details, especially since the walls and the corners of the building are still detectable.
And then I will shortly give some examples about how we could think that we could use this for identifying objects and monitoring changes in the urban environment. And we start with we took this segmented a road surface out of the point clouds, and then we constructed a reference. For the reference, we construct the mesh for it, and then calculated the distance to cyclomedia and the hero delivery robot points to this mesh. And the blue one is it's on top of the mesh, and the red one is on lower than the mesh, and the white is quite it's on the same level. And here we can see that the cyclomedia is geometrically and topologically quite well aligned. This is after with ICP with the dataset, and then we can see some patterns there. But hero delivery robot data, well, there is a road there, and it's but the accuracy is quite low. Then we also segmented this tree, and again we can see that the hero delivery robot data, we can see that there is a tree, but the accuracy is quite low. But we can notice two things when we compare this to the cyclomedia and Leica data. Firstly, the colors are much better in cyclomedia, probably because they had much better lighting environment, and we had this overexposure because it was a sunny day. And the second one was that the density is getting significantly lower higher can we go compared to our to the reference data which has consistent density. And this could affect, if you want to calculate the tree height or the biomass, this could affect the accuracy of those results. And finally, this funny little real-life example of this change detection, we noticed in our measurements that there is this electric box during the intersection. And it was straight up during the circular media in 2022, but it was a little bit tilted after that. So this tilt became more severe after an autumn storm, as can be seen in this City of Helsingin Sanomat news article, and it topped over the car. But thanks to a good city management, a couple of weeks later, it was fixed already. But for kind of cyclomedia, if can be a good temporal frequency of the data and good data processing powers, pipelines, these kinds of things can be detected before they actually happen and hurt someone's car.
Yeah. For final conclusions, we think that cyclomedia offers a good low resource but decent accuracy alternative to this terrestrial laser scanning, which can be quite expensive because of the equipment and the time that it takes to make the scannings. So it has potential in multiple applications, such as identifying objects and monitoring change in the urban environment, as we heard from Juho and Anna. But as said, the Hero delivery robot data doesn't have good enough density for many of these applications that require high accuracy. But we think that it might have some potential in large-scale city models where the only low level of detail is needed. Yeah.
Thank you.
Thanks.